we can get started.
Sure. Good morning.
Did someone say something?
Yes. Good morning. Good morning, Shishender.
Hey,
Good
good
morning,
morning.
all. So, so I'll be demonstrating the project which I have deployed. It is the Cosmo project that I have worked on, and we have implemented CI/CD pipelines there. And I'll be sharing my screen now. Okay, is my screen visible, Shishender?
Yes, I can see.
Sure. So so in the last time, you wanted to see the CI/CD pipelines working. So, and I'll be demonstrating you those things. So this is the A case in which we have deployed a project. Just give it a minute. It is loading. And this is the pipeline that we have built. In this project, there are 4 microservices, and these are the pipelines that are associated with it. In which I have deployed them into AKS and and also I have deployed them into ACR. So, uh, so how the deployment happened in Plasma project is for two backend services, I have deployed it using CI/CD pipelines directly into AKS, and one what I did is I deployed it into ACR. From that, I have created a single image application this in this manner. Then I have deployed that image in my Kubernetes cluster. So AKS Cosmo Dev, this is the Kubernetes cluster I have created, and Shinder, these are the services that are built after deploying my microservices. So these are the IP addresses which I have got. If I click on this, we will get the Swagger page of this client microservice, and these are the APIs associated with it. So I would like to show you the uh, CI/CD working of it, where I'll be making some changes in the code, and it will reflect in the Swagger page. So I'm going to the controller layer of it, and I'll be modifying the API name so that we can see if the new changes are visible. So as you can see right now, let me work with this edit API or any API in this, and we'll see if the changes are being reflected. So since it is associated with edit API, so this is the API that we are going to change. So let's change it to from edit to change ID, and I'm committing this change here. Um, so I got two of my pipelines working. So this pipeline will be pushing that image into ACR. So I made this for my reference, and having a separate backup to my images. So I'll be canceling it for now, and I'll be demonstrating it in the AKS directly. So this is the build that is happening right now, and this is the
So could
build
you go
stage.
inside? Yeah. Like,
Yes,
so what is written in this build stage? Like
yes.
what it is
So
actually doing?
basically, there are two stages that I'm executing here. One is when we build the Docker image out of our application, out of this microservice, and we push it into ACR. And after that, what happens is our AKS cluster will retrieve that image and host it into in a load balancer in that particular AKS cluster that we have created here. That is, in our case, in this, a service will be created of the type load balancer, and we will get an external IP here from which will redirect us to the Swagger page. And this is
No,
that
I meant to ask.
particular pipeline. Yes,
I meant to ask. So now you have made a change, and then that change
yes,
is being built or compiled into a
yes,
binary, and then
yes.
you build that. Um, you
Mm.
bake that binary as part of your Docker image, and then you publish the image into ACR, correct?
Yes,
Okay. So okay, let's see. Okay, it's building right now.
it is building this Docker image.
Docker
Just
image.
in 1 minute or two, it will get deployed into our AKS cluster. Then, as you can see, this is the previous one, right? I have
Mhm.
shown you. This part of this API will be changed.
Sure.
So yeah, now deployment stage is here. Just in a minute it will be over. So meanwhile, I would like to take you through the YAML page, which has all the tasks defined in it, and from and it is the core. It is the YAML file which has all the steps. So these are the steps that will be followed in our pipeline. So first of all, we are just creating some variables which will hold the data, and we will refer to them in our YAML file using this Docker one. And after that, as you can see, we have two stages here. First stage is the build one, where we have our Docker image built and pushed into the ACR. And as you can see, this is the image repository that we have defined. And this particular repository, we can find it in our ACR. Let me just show it to you. So this is the ACR that I have made. And in this repositories, if I go there, as you can see, client app AKS 002. So this is the one which we have defined here. Get to our client app AKS 002. So this is the image repository in which the Docker image which has been built is deployed, and from there it is retrieved by from the AKS by AKS in this deploy stage. As you can see, environment is defined here in the deployment stage, and we have different steps of Kubernetes where it will use this image full secret to to establish a connection with our ACR and pull the image. After that, we have two of our files here, that is deployment and services, which are defined in this manifest, where let me show you. It'll it has the app name in it. This is the same name as we have defined it in our services of cluster, and this is the image that it is retrieving. So this link refers to the image that we have built in our previous stage, and as you can see, it is using, as you can see, this from manifest, it is executing this deployment.yaml file and service.yaml file. In this deployment.yaml file, we have defined which image it has to pull from ACR and deploy it into AKS, and in and this is how the deployment happens. And in service, we will define what kind of service it will be. For example, in our case, it is load balancer. Also, if we use an external IP for us where we are hosting, where we have our own domain name, we can use the type as cluster IP and redirect it to our domain name. So, in this pipeline, I guess this pipeline uh, will be built. Yeah, the deployment happened here. So I'll be showing you the latest changes in our Swagger page. So I'll be going to the same IP again here, and let me just show you. As you can see, instead of ID, edit ID, we have changed it to change ID. So this is the previous one, and this is the latest one. As you can see, we have this CI/CD pipelines working. as expected, and we can give it to our front-end people to retrieve the data and use these APIs for front-end service. Also, the additional thing that we have implemented in this particular project is role-based access. For example, I'd like to ask Veer to share his screen for a while, because I'll be sharing my screen and showing you what is the difference between mm, uh, for the the access which I have and what Veer has, because I have given him uh, a reader access, and I have I have not given any access to Manikanta. So if I open my screen, and you can see, I can select these services, and I might delete them also. However, this access is not given to Veer, so he cannot delete it. So I'd like to ask Veer to start sharing his screen.
One question before you
Oh,
get into the
yes,
access related stuff.
sure, sure.
So you made a change, you built an image, image was pushed
Yes,
into the registry and then it got
ACR.
deployed,
Yes,
right?
yes.
Now, let's say I made an unintended commit, right? Or
Okay.
I have some defect in the commit. Now,
Yes.
there is already a working image, right? Now, when you
Mm.
make a
Yes,
commit
sir.
with a defect or something like that, or a broken code, then your image gets overwritten. So how can we
Yes.
prevent this from happening?
So
We can
we can revert it back to our previous image using, because we will get a we are basically using the latest image. When we when we push the image, it gets tagged
with
with
the
the latest tag. However, if we want to get back to our previous version, we can use the image number of the previous build, and we can deploy it again.
So in
Also,
your
we
case,
can,
your
yes,
pipeline ran
yes,
quickly in a matter of minutes. Sometimes pipeline
yeah,
runs
yeah,
longer or images are huge in nature, right? And I do not
yes.
have the luxury of waiting. So I'm just trying to understand uh, how you guys can think, like in the sense, do you see any alternatives other than going back to the Azure repos, correcting the code and initiating another build? What else can we
So
do here?
we can define some test cases in this.
however
However, we haven't implemented that in our case, but we can implement some test cases, like if some APIs are working or not, we can check it.
so we're here. We can do like we are deploying two different images. We have one build number image and the latest one. So while deploying the latest one, we can override the latest image. But we have storing the other image also, like the build number image. If we got some mistake in our code, we can use the previous image and build again. So it will
Okay.
be fast. And like in the Kubernetes, we have option to set image. So we can type that command and we can override the image.
Okay, sure. This helps. Thank you.
Yeah, thank you, sir.
Otherwise, instead of just setting that image, we can just give the previous number in our deployment file, and we just, if we give a bill to that particular service, it is going to get stored back to the previous version. So in the matter of some seconds or minutes, we'll be having working services. Uh, I will be showing how we did that. Actually, we implemented that in our project. I'll be showing that. So I'm sharing my screen.
Sure.
Hello, sir. Can you see my screen, sir?
No, it's blank.
Okay. Okay.
Hello, my screen is visible.
Yes.
Yeah. So in like in YAML, what we did in the previous demo, we show how we are deploying it using that way. Uh, here. What he showed, he is taking the deployment method in the pipeline, and he just deployed those pipeline and again deploying it, like for latest image, he's deploying again and overriding same image. So what we refactor it, we did this other method. This method, what we are doing here, we are taking here, like in the tag, we are taking one latest image, other is the build number image. This build number image will save our build number in our code, in our ACR repository here in the Docker ACR. We are saving both. So if we want to roll back it, we can use that build number image here from here only. And like previously, we failed to show that why our image is not reflecting when we are deploying. What we are doing, we are not for the new release app, we have to delete the previous pod from the Kubernetes, but we are not deleting that. We are trying to override the same pod. So this time, what we did in the pipeline, we added this delete option. We delete the previous pod, and then we applying all the other things in the Kubernetes, like deployment file and service file, using this another task here, the Kubernetes another task. So this time we refactor it using this thing, because previously we have to do these things manually. We have to type this code kubectl delete and then delete that particular pod. So for that, we added this task here only, and it will delete the previous one and override the new one, like new pod. Here I will show you.
So one question here, Veer. So
Yeah.
You have two tags. One is latest, the another one having the build ID, right?
Yeah.
Now, if I want to, I don't want to rebuild the image, but I just want to go back to a previous image. How do you override this image? You mentioned some set command, but where do you use that?
In the here we didn't use, but in the Kubernetes, so we have that kubectl set image in the deployment file. So in the deployment file, we will roll back the image, but we didn't use here that
Okay.
command.
Okay. Sure.
Yeah.
Or we can just change the tag ID in the deployments also. Can you showcase the deployment?
Yeah. Oh.
Yeah. Here if you see in the spec image, if you just replace that tag with that particular ID, previous build ID. So and we deploy this services, it is going to roll back to the previous version.
But I have to come here and manually edit this file.
Yes,
Right.
or otherwise we can directly
So
change using that kubectl commands in the VM. That
for that, I need to log in into the cluster, right? So let's assume I don't want to log in into the cluster and I don't want to modify the pipeline, but I still want to overwrite the image. How could I do it? Any ideas? I just want to hear your thought process. That's it.
Veer, you're on mute if you're speaking.
Here, like here, what I'm showcasing here, like we are building two images. This one is the latest one. The other one is the with the build number ID.
Mhm.
So what we trying to do, if we want to roll back it, we just take this image ID and we research about it. There is an option in Kubernetes kubectl command. So we thought we can try this to use this image ID and roll back this that using set image command.
Right. So that is more imperative way of doing it, where you log in into the cluster and then you
Yep.
fire a kubectl command and then change it, right? Let's say
Yes,
I don't
yeah.
have access to my cluster. I don't have access, and I just want to change or deploy my latest image. Let's say I want to deploy 1961 or 1951, that tag, right? And I don't have access to change my pipeline as well, the YAML file. So do we have any options, or how could we write the YAML file in such a way that people who don't have access to YAML file can still deploy it?
Deploy the previous one. I like we will try. I don't know the correct answer, but I will explain.
There is no right or wrong. I just want to hear your
Like
That's all.
we can add in our YAML file to remove the like when we can add one more task. There we can write one script. If someone want to roll back it, we can write one task. If someone want to roll back, he can delete that Docker file, which is the latest one, and override the previous one. We can maybe apply this thing.
Okay. Sure.
Or we can create another CD job where we can use a Helm chat and we can pick the particular image and give a release for that particular service. But we
Okay.
haven't tried using Helms, so
Sure. This helps. Thanks, guys. Veer, you're talking on mute.
Sorry. I will showcase this way of deployment, like how we are deleting our pod and releasing this pipeline. So and the change will happen in my code here. Like I have deployed here in the admin B. I will change this user/admin URI here URL. I'll go in the code. B source. Here's user permission controller. Here I will delete here this one user permission add. Just add to add user and configure. Here configure to add and just commit it. Pipeline will automatically start building. Here, like I said, we added 2 tasks for Kubernetes. I'll show if command here. Here, like we have this here, this pod right now, and what I am doing in one task, I am deleting this pod from here and replacing with the other pod. So it will change my latest image. For the new release, we need to delete the older pod, because older pod what the older pod doing, they store the cache of that previous image. So that image is reflecting us again and again from the cache. It take that image and not showing the latest changes. That's why we need to delete the previous pod before deploying the new cluster, before doing the new release. It is happening.
Okay, while this is running, I had a quick question for you guys. So you remember we were trying to attempt a change last time, which didn't reflect, right? Did you guys go back, try to figure out what went wrong?
sir. Actually, last time what's happening is the pods what we are deploying now, they're using instead of pulling the latest image from the ACR, they're using that cached image what are there in the cluster. So because of that, what are the changes we are making and whenever we're building a new image, it is not taking the latest image. And in the deployment YAML file also, we didn't specifically mention the tag name as latest. By default, it's supposed to be taking latest image, but instead of taking the latest image, it was taking the cached image. So that's why we added this new step here in the Kubernetes in the pipeline YAML. We added this particular Kubernetes step where we're delecting the previous pod and we're just creating a new pod, and which in turn pulls the latest image from the ACR. So if you can see there, the digest of the image also changed. It is taking the latest image, and we can see the what are the changes we made. It gets reflected in that particular page.
Okay.
Here you can see instead of add, there is add user, add user. It will change here or just running the pipeline. So it will good for the developers, like they don't need to go again and uh, build again and all. They just make changes, commit it. It will reflect the change directly. So that's why we added like this way.
Could you go back to the YAML file one more time?
Yeah, sure.
So we are deleting the pod and then doing apply again.
Yes.
Okay. So any specific reasons why we are doing this? Like, I mean, probably in case you have explained
Yeah.
again, please explain again.
Yeah, like before I explain, because we are deleting it like for in Kubernetes for new release, we need to delete the previous build, previous pod, and like apply the new pod. And because the previous pod, what doing, it's storing the cache of that previous image. When we are building it again and again, it will reflect the only previous image, because it has the cache of the previous image. For the new app release, we need to delete it and then apply the new one. So it will show our changes, whatever changes are there.
This is because we are using the same tag. Is that the reason? Or in general, it works like this?
No, in general, it's work like for the new release, we need to delete the previous pod.
Okay, so just to add here, we need not worry about deleting a pod. And that's where the Kubernetes framework does, right? So anytime you have a new image, you can just say kubectl -f apply, apply -f the file name. Whatever is the latest image specified in the deployment YAML, that would be taken and then applied. So we need not go and manually delete the pods.
Yeah.
Unless and until you have any specific reasons or you have specific issues you are facing because of which you are doing this. Otherwise, the general approach is you don't need to worry about cleaning up pods. It's normally taken care by the framework.
Yes, sir. Generally, the flow should be like that, but we're also not sure why we're facing this issue. So while normally before also we didn't mention this step, and we thought like in the flow it will gets deleted and it gets pull the latest image and everything, but that flow is not happening. So that's why we manually doing this.
Sure, right. Okay, yes. This looks good. That's all I have.
Yes. And previously in the last interaction also, we faced some issue regarding that file, which is taking like more time, like 54 seconds or something. So about that, we also researched about that. That is not the issue of our build and process. In that particular file, we're calling some other service to get that files, some extra files, some files from that service. At that time, while we're giving the build, that service is down. So that's why it is taking that much time to load. It's like it is taking nearly like 50 seconds or something. If we do that now, it is working fine and everything is going smooth. So
Okay.
Guys, in our first interaction, I asked like, is there any slide or anything, any documentation where each of the individual works is mentioned, like rather than we, I have done something like that. Is there some documentation where I can see, yeah, Dinesh have done these tasks, Veer has done this many, and Sai has done this many? Is there something like that? Individual responsibility, something you have taken.
So we have different projects assigned to us, and we have worked on that. Basically, Ross work has been done by Veer and Sai, and Posmo deployment is done by me, as starting from how to create a creating a Docker image, then deploying them into ACRs, and then into a case. So though that part and building pipelines and establishing those repositories for whatever work is done in Posmo, like I took care of it, and the Ross, Veer and Sai worked on that. So, and for regarding the documentation, our work was simply divided in among us, so we did not need that document at that time. So we were clear with what we had to do.
Okay. And Veer or Sai, can you bifurcate Ross also a little bit here and there? What responsibilities were you guys playing?
yes, sir. Actually, what our plan is to we really segregated particular jobs per particular person. We want to have complete exposure to all the fields and all the things. So we didn't specifically mention. So that's why, sir. We created some services. I created some services. We secured together only. We secured everything. And this writing this deployment YAML files and this Azure pipeline files also. We want to have that complete knowledge on that complete flow. So we didn't specifically work in single topic.
But in the end, it is the one guy who is going to write. But
Yes, sir. Yes, sir.
you said some services you wrote, some services we wrote. So
Okay, that's fine. Take it easy. All right. So, any other questions you have, Sushinder?
I'm good, Ashok.
Okay, you have any?
I'm good.
Okay. All right. Thank you, team. Appreciate you circling back so quick. And Yogita, I'll give you a call.
Sure,
Okay.
Ashok.
Thank you, sir.
All right. Thanks,
Yeah, thank
guys.
you.
Take care. Have a
Okay,
good
thanks,
day.
guys.
Thanks. Bye.
Thank you, sir. Later.
Thank you, Ashok. Thank you, team.
Bye.
Okay. Manikanta.